Let's begin our section on networking of computers here in the A+ course with a look at network cables and connectors. That's right, we need to connect these devices together in order to be able to make them communicate, and there's many ways we can do that today. As a matter of fact, we could decide we're not going to use a cable or a connector, and that would be connecting via wireless. And we will certainly have nuggets that deal with wireless since it's so popular today. But cables and connectors are certainly used as well. Let's get started. Now, as you know, I am super careful in this course to cover absolutely everything in the blueprint and do it in order for you so you can easily coordinate the nuggets to the blueprint materials. When you look at this section of the blueprint, you'll see that they do connectors and then they do the cabling. So what I decided to do, because it makes such sense here, is I combined this material. Now, to make it easy for us, I will stay in their order. So I'll do fiber, twisted pair, and then coaxial. But we're going to talk about the fiber types and speed and transmission limitations, for example, and the connectors for fiber, and then we'll move on to twisted pair and coaxial. In fact, let me show you my combined approach that we'll use in this nugget. Ah, yes, that looks a lot better. So notice it's 2-1 and 2-2, and I'll go in the order that they suggested of fiber, twisted pair, coaxial, although that order is kind of funny because twisted pair and coaxial, they're so common you probably are using those for networking right now in your home. You might not be using fiber. So this order is not like in popularity or commonality that you might run into, but we'll go ahead and do it that way. Fiber, twisted pair, and coaxial, and we'll cover connectors and everything else in a grouping that makes sense. By the way, I took this particular outline that I am using and I placed it in your Nugget Lab files in case you want it to coordinate it to the official blueprint from CompTIA. So how amazingly cool is fiber when it comes to networking our devices together? Really super cool. What we do is we have this piece of glass, and this central piece of glass is called the core, and we send light down that core in order to transmit the information. Notice there's all this cool looking stuff around the core. This is called cladding, and it's all there to protect that fragile core inside a fiber cable. So what's the advantage? Why is this so cool? Well, one word: speed. Absolutely. If we use this technology, we can move data super fast. Why do I love fiber so much? Because in my neighborhood, I'm taking advantage of a product called Verizon Fios. Fios stands for Fiber Optic Service, and they bring fiber optics right up to my home. Then I carry that signal into my home using other technologies that we'll talk about in this nugget. But the bottom line is fiber optic connections are being brought right up to my home, and I can get 300 megabit, 500 megabit per second internet speeds. And this is incredibly fast when I'm watching movies and downloading content, or even more importantly, uploading nuggets that I've recorded for you up to CBT Nuggets. That happens very quickly compared to other technologies. There's two other things that happen for us when we use fiber optic in order to transmit information, and that is we can go long distances compared to other technologies, and we've also got a bit more security here because it's really tougher for someone to intercept the information that's being transmitted by that light inside the core. But think about it. Is this going to be an expensive solution? Yes, it sure is. And think about the flexibility of this particular cable. Could we grab it and bend it? Could we make multiple bends in it? The answer is no, of course not, because we're dealing with glass inside of this technology, and we could easily break or have internal breaks in the cable, which would make the transmission no longer flow. Now there's two variations of this type of cable that we need to know. There's what's called single mode fiber, and then there's multi-mode fiber. With single mode fiber, we use a really tiny core and we send a single light path down that tiny core. The advantage to this is that it's really fast and it can go super far. But if we use multi-mode fiber, we'll use a much larger core and we can send multiple light paths down there. This is great, but we can't go as far because we're dealing with the multiple light paths. As we get larger distances, there's too much that can go wrong and we simply can't send the information that far. So with single mode, we use this in wide area networking, for instance, and then multi-mode we'd find in our local area networking. Wide area networking is a way to describe large geographic distances for sending our networking, and local area networking means like smaller distances, like a small office, home office would have a LAN. You and I will get deeper into the different types of networks we can create, by the way, in a nugget called internet connections. So I mentioned Verizon is one of the companies that's leveraging the power and the speed of fiber, but Google's another with an initiative called, of all things, Google Fiber. Look at this. This is a Google Fiber connection versus a 10 megabit per second connection. 10 megabits per second is something that I get. I actually get about 7 megabits per second with a DSL connection at my remote office location. So I can see here what fiber would do versus that connection. We'll start a race and we're downloading 100 photos. Notice the fiber connection, we're done. And the DSL connection, still laboring at that particular download. Notice you can check your address here to see if Google Fiber is available in your area. So if we look at single mode fiber, and we remember single mode fiber is designed to go those long distances, what really is the measurement values? Well, if we look at a variation of single mode fiber called 10G base ER, and we break down that, by the way, we see that it's 10G at the beginning of the name because the maximum speed of this technology is 10 gigabits per second. So lightning fast, no pun intended. It's baseband technology, and the ER stands for the particular specification that we're dealing with. So we have this 10 gig possible speed. How far can this go? 40 kilometers. That's about 24 miles we can run this particular technology. It sounds like a marathon. I think a marathon's like 26 plus miles. I'm running a half marathon next month. I should know that. So anyways, you get the idea here. We're talking about a really long distance with these technologies at a high speed, just like we described. So we said multi-mode fiber just can't go as long, and that's absolutely true. Let's look at an example. 1000 base LX multi-mode fiber technology. The 1000 means we can send this particular technology at a speed of 1 gigabit per second. Okay, that's fast. Not as fast as the single mode fiber that we looked at, by the way, but it's fast. But the problem is distance. It's 550 meters. That's about 0.34 miles. So we had one technology that could go nearly the distance of a marathon, and now we have a technology that's not even a 5K run. So you can see big differences in the distances that are possible with this technology. Now, how do these fiber optic cables connect to equipment? Well, there's three common options that we need to know. In fact, the most common is called the ST connector, and it's right here. This stands for straight chip, and it was developed by AT&T. You see this a lot. Notice it's got this little British naval connector locking mechanism. So we push it in there and then twist and it locks into place. This is obviously really simple and powerful to work with, and that was one of the reasons why it's so popular. We also have the SC type of connector shown here. This stands for subscriber connector, but lots of network engineers that I work with will often call this a square connector. And you can see why they would say that, this square piece on the end. Notice you push this in and it latches in, and it's pretty much impossible for you to pull that thing out without releasing the latch that's on the side. You'll find the subscriber connector in single mode and multi-mode optical fiber environments, but they're not nearly as popular as the ST when you're dealing with a local area network, those short runs of multi-mode fiber connectors as you would have with the ST. And the last type that I want you to know is the LC. This stands for local connector, but again, a lot of engineers will call this something different. You see, this connector type was developed by Lucent Technologies, so many engineers will say this is the Lucent connector. This particular connector, as you can see, works a lot like the SC connector. Now notice this one has two kind of paired together. This is a duplex variety that you'll often see, where one is used for sending and the other is used for receiving. Now, if you've bought any kind of networking device, I bet you've found this in the box along with that device. Like maybe you buy a nice wireless access point for your house, and they'll throw one of these cables in so you can initially connect to the device and configure it. Or you buy some smart lights for the home that will connect to your wireless device with one of these cables. We are utilizing copper inside of this cable in order to transmit data now. So we saw with fiber where we would use the glass and we would use light inside that glass to transmit the information. Now we're using electricity running over copper. This is called twisted pair cabling. There's these little strands of copper and they twist it so there's less interference. Now there's unshielded twisted pair that we see here, or there's shielded twisted pair. Unshielded means there's less protection around the copper. Shielded twisted pair is more expensive and there's more shielding around the copper, and you would use this where there's going to be areas of really high potential interference. So when you look inside the unshielded twisted pair, if you dissect it, you can see that we have these 8 wires inside, and they twist them into 4 pairs. And notice that there is a coloring scheme. There's orange and orange and white, green and green and white, blue and blue and white, brown and brown and white. When we take these individual wires and we put them into a connector, we need to obviously arrange them in a specific color pattern. Now what's cool about our connectors is they're clear plastic typically, so we can see the wires inside the connector and we can see how they're arranged. There's 2 common standards for this. There's T568A and T568B. So if you look inside the clear connector and you see the orange-white, the orange, the green-white, the blue, you get the idea. If you see this arrangement, you're dealing with the T568B. If you see this arrangement, which doesn't start with orange but starts with the green, you're dealing with T568A. So I just grabbed a piece of cable in the office here that came with one of my network devices, and I hold the ends of the cable so that the clip portion of the connector, and we'll talk more about the RJ45 connector in a minute, but we hold the clip side away, we hold the 2 pieces up next to each other, and sure enough, I can see that both ends of this cable are colored this way, so I have a T568B piece of unshielded twisted pair. Both ends are arranged this way, and we call this what's called a straight through. Let's see, how do you spell straight? There we go. Straight through, often called patch cable. This cable is designed to connect one networking device like a computer to another networking device like a switch. Absolutely. Now, here's what's interesting. There can be a crossover cable that we deal with, and you guessed it, one side of the cable is pinned out or colored this way, and the other one is pinned out that way. So when you hold this cable at the ends up next to each other and you examine the color scheme, you see that they are changed. They're crossed over. This type of cable is used to connect two identical devices. Maybe you have a computer and you want to connect that computer directly to another computer so they can communicate. Notice they're the same type of network computer, so we use a crossover cable so they can communicate directly with each other. What you're doing really is you're twisting the send and receive signals. So one is using the send side directly to the other's receive side. So there's two connector types that we want to be familiar here when it comes to our copper twisted pair, and that's the RJ11 and the RJ45. RJ stands for registered jack. And the funny thing about this is the RJ11, your grandparents are super familiar with, and they've been using that because what do we use the smaller RJ11 for? You guessed it, the plain old telephone system connection. When you plug in a phone into the wall jack, as you've been doing, your parents have been doing, your grandparents have been doing, your great-grandparents have been doing, that's what you're using the RJ11 connector. We know that the RJ45 that we use for our unshielded twisted pair today to make computer connections, it's bigger. Yes, that's really the only difference between the two. Same type design. We have the little clip that will lock this into place. How many times have you accidentally tripped over the telephone cord and you may break that connector? It's happened to me more than once. Now, something else that we need to understand about unshielded twisted pair is that there are different categories of this particular cable, as we can see from this blog. So there's Cat 3 and 4 cables, and they're so old that you're going to have trouble finding them. And then there's Cat 5 cables, and they're going to operate at 100 megabits per second for 100 meters. And then Cat 5e, which jumps up to a gigabit per second capability for 100 meters. Cat 6, a gig for 100 meters. Cat 6A, which jumps up to 10 gigabits per second. Notice there's a variation of Cat 6, which gives you 10 gigabits per second at 55 meters. Then Cat 7 at 40 gigabits per second for 55 meters. Cat 8, you get the idea. Notice this blog post on Cat 5 cabling. Took me a second to get that. Oh yeah, those are cats. I get it. So let's bring this to life a little bit. Let's go to Amazon.com and let's do some shopping for unshielded twisted pair cable. And I'll hit enter. Notice this link right here. This is interesting. It says, okay, 5-star cable, 1,000 feet of it. It's Cat 6 unshielded twisted pair PVC cable. Wow, so we get 1,000 feet of this cable for, how much is it? $64. Now notice, you would be taking this cable and you would be cutting it to the lengths you need, and then you would be attaching your RJ45 connectors so that you could utilize it. And I have a particular nugget for you called Network Tools, where you'll see the tools that you would use in order to make up these cables if you wanted to make your own. Now, something that's interesting here is that this is called PVC cable, and that's something we need to understand. There's PVC type cable. It refers to the shielding that's around it, even though we could say it's unshielded twisted pair. We know that it's coated with something, and that's PVC that's coating it. And this is in contrast to plenum cable. What's the difference? Plenum cable is going to be more expensive. In fact, let's look for it. So UTP cable, and I'll say plenum. And let's see. Here we go. And look at the price just jumped up, didn't it? Are we dealing with 1,000 feet? Yeah. Now this is Cat 5e, and we were dealing with Cat 6 before, I believe. But notice the price still jumped up. And that's because of the fact that this cable is going to be rated so that it won't catch fire and create all these fumes, that it will be far less combustible than PVC. And this is great for running across ceilings and things like that, where you don't want there to be something that's really prone to fuel a fire. So keep that in mind, that we have different grades of the unshielded twisted pair for where we're going to run it. If we're not concerned about adding fuel to a fire, we can go with PVC. If we have to be real super careful about fire, we'd go with plenum. Now, by the way, what if you've only got a single wall jack, but you desperately need to connect two devices? Well, this is why you would have a splitter in the twisted pair world. Splitters are nice and convenient for the situation I just described, but keep in mind that splitters are always going to have a chance to degrade the quality of your connection. So we really want to try and use them as sparingly as possible. Now take a look around the television in your home and you're going to find yet another type of network cable, and that's called coaxial, or we often just abbreviate this when we talk about it and write it as coax. Here you can see an RG6 and an RG59 type of cable. There's a slight difference in the diameter of the copper core. RG6 is slightly larger and it gives you a really good signal for things like your satellite or cable television. And why we care about this is that we can also use this to make high-speed internet connections possible over the cable technology. We use what's called a cable modem, and we get high-speed internet in this way. I'll elaborate on this, of course, in our internet connections nugget. So, yet another way to network devices together. What kind of connector types will we find with coax technology? Well, something fancy like the British naval connector that we saw actually replicated in a fiber cabling environment, or what we're very used to in the home when it comes to cable television. This is called an F type of connector. Now remember, we want to use splitters oftentimes to take a cable and split it off into multiple cables, and this is certainly popular with coax. But in a lot of cable television situations, you'll have splitter after splitter after splitter, and sure enough, that can cause signal degradation once again. So many times you'll see in older homes, when you try and upgrade your technology, the cable technician will come in and he will literally eliminate a whole bunch of splitters that have been utilized and maybe even run new cable. Now, what about speed and distance? Well, if you look at RG6, for example, it can run about 1,000 feet. And as far as speed goes, we don't measure speeds here like we do with the other cable types. So we're not saying, okay, you can have 1 gigabit per second of speed on this particular cable. What we care about is that we know when we're using cable modem technology that it can carry more than enough data for us at a great rate of speed for us to use it for a high-speed internet connection, for example. So we took a detailed look, as you saw, at fiber cable, at twisted pair cable, and at coaxial cable. Now, in this nugget, I shared with you that I utilize this Verizon Fios service for super highly reliable, super fast internet at the largest of possible costs that I would spend here locally, I might add. Now, let's take a look at the cabling that's involved in my home, because we're going to find all 3 cable types are utilized in my home office. Here's the outside of my home, and notice here is the fiber optic cabling that's coming up from the street. What do you notice about this, by the way? Look at right down here. See, we have these driving rainstorms in Florida, so what I'm getting here is some erosion at the base of my home, and you can see the inner fiber optic cable, if you look really close, is actually exposed here before it goes up into this protective coating along the side of the house. So what I really need to do is fill this in with like rock and dirt to protect this. I could have the lawn guy easily damage this fiber optic cable when he comes along utilizing his equipment. So, you know, one of the things with me in A+, I'm spending a lot of money as I teach this course because I'm seeing all this stuff that I want to buy, and now I have a honey to-do list. Whew, yikes. Anyway, so we can see the fiber optic cable coming up to the home. Next, we're going to take that fiber optic cabling connection, and we're not going to run fiber throughout the home. Instead, we're going to run it into the existing coaxial that's in the home. So here we go on the other side of this wall right here. This is the exterior wall of the home. Now we're on the other side of that. We're in my garage. And this is where Verizon installed this Mocha equipment. Now it sounds like a caffeinated beverage, but what Mocha here means is that they're going to go ahead and take the data that's coming in off the fiber optic, and you can see it right here. That's coax. So they're going to go ahead and take it and move it over the existing coaxial in my home. So now we've moved from my garage into my office, and you can see the coaxial right here plugs into a wireless router that they equipped me with, and then we go unshielded twisted pair to particular devices. Here you can see this device right here, which is plugged directly into my wireless router with the unshielded twisted pair, and this device is the Hue Lights Control Center. So this is controlling the smart lighting that is throughout my home. One more little detail about that, by the way. I have that connected to Amazon Echo's product. So we can walk into our home and we can say, Alexa, the name of that little robot. We can say, Alexa, all lights on. And she will turn on the lights via voice command thanks to the Hue Smart Lighting. But I've gone a little bit ahead of ourselves here. What the point is here is that look at my home. This is my home, and we have fiber, we have coax, and of course we have unshielded twisted pair. All three of the cable types that we looked at in this particular nugget exist throughout my home in order to make the networking possible. By the way, what else is happening in the home? This device we said is a wireless router. So sure enough, this device is connecting most of the devices in the home through a wireless signal. And as I promised you, we will have nuggets specific to wireless. So we covered a lot of information in this nugget about network cables and their connectors. And we saw those three major categories of fiber, twisted pair, and coax. In that order, we covered them in this particular nugget. 2 sections of our A+ blueprint for 1. I love 2 for 1. So I sure hope this nugget was informative for you, and I'd like to thank you for viewing.